Now let's suppose you want to estimate the height of a building. I mean, you don't have precise equipment, but you can still make a good estimate of the height by what we call the triangulation. So let's say that this is our building, and nearby you have a pole, which by just putting yourself there or your friend there, you can estimate that the height is, let's say, 3 meters. And then you take 2 large steps. Each large step is more or less 1 meter. So if you take 2 large steps, you are 2 meters away. And when you look at the tip of the pole from these 2 meters, you see along the same line the tip of the building. Well, if you don't have a pole, you can put your friend there. You know the height of your friend, that will be typically around 2 meters. And then you can just take 2 steps to one side and lean down or up, so that when you look at the head of your friend, you see at the same line the head of the building. So, and you just need to estimate the height of your eyes from the ground. So that would also work instead of using a pole. So let's say that this is our setup. There is a pole. You are just around 2 meters from the pole. You know your height. Your eyes will be slightly lower than your height from the ground level. So let's say that your eyes are around 1.5 meters from the ground. And you also need this distance from the building. Let's say that you take large steps from the building to the pole, and it turns out to be 16 steps. Well, that would give us an approximately 16 meters. So the pole is 16 meters from the building. You are 2 meters from the pole. So when you are 18 meters from the building, when you look at the tip of the pole, along the same line, you see the tip of the building. So with this information, you can determine the height. So to determine the height, let's look at this triangle over here. So let me just draw that triangle. This is our building. This is our line of sight. This is the line of sight. This is the height of our eyes from the ground. We know that this height at a distance of 2 meters, this height is, the pole is 1.5 meters. The pole is 3 meters, your eyes is 1.5 meters from the ground. So this height is just 1.5 meters. So you see here you have a small triangle and a big triangle. The big triangle has this side, since this distance from the pole to the building is 16 meters, the total length of this side is 18 meters. So you see here, this is the small version of this large triangle, and the large triangle is 9 times 18 meters over 2 meters, 9 times the small triangle. Well, if the larger triangle is 9 times the smaller triangle, just looking at these sides, all the other sides should also scale by a factor 9. So if this is 1.5 meters, this height should be 1.5 meters times 9, which is 13.5 meters. So we see that this height is 13.5 meters. And keep in mind that this height is not from the ground, but from your eye level. But your eye level is 1.5 meters from the ground, and this is 13.5 meters. This is 1.5 meters. So you can estimate the height of the building to be 15 meters. This would typically corresponding to a building with 5 floors. In fact, if you could have just knowing that if you look at the building and you see that the building is 5 floors, you could estimate this 15 meters. And if you don't know the distance, using this knowledge of 15 meters, you can just show that this height, this distance should be 16 meters by just going in the opposite direction. Let's say if you know that the height from your sight eye level is 13.5 meters, if the pole is 1.5 meters, that would tell you that this large triangle is just 9 times this small triangle. So if you know this distance to be 2, then you can estimate this distance to be 18 meters. So you would be away from 18 meters. In fact, this way you can estimate the distances of the objects that are very far away from you. Instead of this pole, another thing that you can use would be just the distance between the knuckles of your finger, of your hand. So typically, this distance is 2 centimeters. If you straighten out your arm, this length would be typically 1 meter. And by estimating what fits within this 2 centimeter vision at a far away distance, for example, you can just fit, if you see a 5-floor building, you can just estimate the distance of that 5-floor building. Or if you see a tree, trees typically have heights of the order of 6 to 10 meters. Knowing this information, you can estimate the distance of the tree.